Okay, good afternoon, students, grade 7 physics. Students, we are going to record lesson 2, distance or displacement. So today, kindly open your modules to lesson 2, distance or displacement. Don't forget to read the gems for thoughts. It says distance is the journey, displacement is a result by Jacqueline Moriarty. Our objectives for today is to describe the motion of an object in terms of distance or displacement. So let's focus first here, distance or displacement. And then we are going to differentiate the quantities in terms of magnitude and direction. And we are going to create and interpret the visual representation of motion of graphs. As you can see, we will start with adventure. Now, we have here a picture. We have here a picture, and this picture will show the distance and the displacement. So, there is a question. Is the total distance always equal to the total displacement? Explain. So, as you can see, um, the boy who is riding a bicycle starts with this starting point or this reference point to the east. So he traveled 4 meters. And then he also traveled 3 meters going to his school. So this is now the boy's total distance. While the total displacement is this one. This serves as our shortcut. So as you can see, the total displacement and the total displacement and the total distance is not always equal. Okay? So, let's try to define distance and displacement in the chat with the expert. Distance is the total length covered by the moving body. So, this is the total length covered by the moving body. And displacement includes length and the direction of the objects, path from starting point to the end point. So in here, a best illustration is Richmond traveled a path as shown by the black arrow. So this is the path of Richmond, 100 meters. And then going sideward 300 meters. And then going north 100 meters. Going east 100 meters and going north 100 meters until he reached his school. So this means this is the total displacement. So in order for us to calculate the total distance, we are going to add 100, 300, 100, another 100, and the last one 100. That results to 700 meters. That is the total distance. Well, the total displacement is this straight line. That means the shortcut way. So the total displacement is being can be find out through the use of ruler. So which is equal to 5 centimeters 5 centimeters in your ruler, which is equal to 500 meters. Now, how did he get the net displacement or the total displacement? So we have here an example. Okay, so as you can see, we have here a given right triangle. Every time we find a right triangle, we we can say that this right triangle we can apply the theorem that a certain mathematician made or discovered. So Pythagoras made a Pythagorean theorem, which is c squared is equal to a squared plus b squared. Okay, let's label the following. There is a given here, the b, this line here is, or this distance is equivalent to 400 meters. And then this line here is equivalent to 300 meters. These are given already. So we label it b as base and a as altitude. And then this line here serves as our c. So the c here stands for the the total displacement. Okay, for example, a certain person traveled from this point, okay, to this point, okay, and then from this point to this point. So we have now the total distance. This one is the total distance. Okay, and the other one, okay, so this serves as our total distance. This black line serves as our total distance. And our total displacement is here. This one. Okay. So our blue line serves as our total displacement. Okay. So we are already here in our formula. We are going to substitute the value of the A, which is 300, this one, and the value of the B, which is 400, this one. Okay. So, since our formula is squared, A is squared, B is squared, and C is squared, we are going to square also the A. So, 300 squared, 400 square. So, 300 square means 300 times 300. And then 400 square means 400 times 400. So 300 times 300 is 90,000. 400 times 400 is equivalent to 160,000. Let's add, and then it results to 250. Since we have this square for C, let us extract the square using the square root. So let's get the square root of the both sides. So using your calculator, we are going to get now the square root of 250,000. Okay, so the square root of 250,000 is, okay, the square root of 250,000 in your calculator is 500. Let me show to you, sorry, let me show to you the how to compute. We have here, okay, our calculator says 250,000 and its square root, so it's 500 meters. So this is an example of calculating the total displacement. On the other hand, we have another example. Okay, let's move forward to our apply the concepts. So this is very easy. Okay, on his way to school, Jed travels 100 meters. This one, 100 meters. North, 300 east. 100 meters north, 100 meters east, 100 meters north. So through this drawing or illustration, you can compute the total distance and we can determine the total displacement made by Jed. Next, let's have problem set number 2. As you can see, we have an object moves from point A to point B and to point C. So find the distance covered by the moving object. So what's the total distance covered by the moving object? Okay, it's very easy. Look at the diagram and find the magnitude and the direction of the displacement of the object. So since the object is going to the right, so it's east. So you just have to put the direction as well as the magnitude in order to get the displacement. Okay, let's have problem set number 2. So here, I'll illustrate to you the problem set in the application in apply the concepts. So as you can see, a physics teacher walks 4 meters east, this one, and then 2 meters south, and then 4 meters 4 meters west. So southwest, asa man dapit ang west? Dapat diri ang west, no? This one. 4 meters west. Ano di ay? West di ay ni siya. Copy. Here. Okay, and then 2 meters north. Na. Two meters north. So draw a diagram. Okay. So this serves as our diagram. And the questions would be what will be the total distance and what would be the total displacement. So let's try to look at the given. So this serves as the total distance. You add all this one and the displacement. It goes back to the reference point. So what do you think is the total displacement? Okay, so you have to get the total displacement, we can solve it this way, like 4 meters east plus south, going south, so 2 meters, that serves as a negative because it's south, and 4 meters west, since going west is negative, and then 2 meters north. Going north is positive. Okay, so always remember that in our Cartesian plane, we should always remember that north is always positive, south is always negative, and then west is always negative, and then east is always positive. So north, it's positive, and then south is positive, east, this is east, and then west is always negative, and then south is always negative. Okay, so that's it. Thank you and good day.